Welcome back, guys. On this video, we're going to just take a look at the question paper which is from Limpopo. So this is a May-June exam paper 1. So this was supposed to be written for 3 hours and it is out of 150. So if you want this question paper, you can check the description box there, download the paper, and also if you need some specific questions that you need to take them, you can check the description box. Also differentiate the times that they can be able to, like, let's say for example you need question 2 or question 3, you can click there and just go to the question that you like. So without further ado, let me just quickly start, because I'm not going to read the instruction. The instruction is for you to read. I'm going to just quickly start with question 1. So here's our question 1. So question 1, it carries 30 marks. Let me just start with 1.1. So here's 1.1. They say solve for x. So as you can see, guys, that this is a difference of squares. So what we do, we're just going to open two brackets just like this, which is equal to 0. We put x, and x, we look for the square root of 121, which is 11, and 11, and we'll put different signs just like that. From here on, we can have x, which is equals to negative 11, or x, which is going to be equals to 11, just like that. So with this, we take this term off. The next question is this one, 1.2, is also solved for x, but they say correct into 2 decimal places, which is worth 4 marks. Once you see this, just know we're going to use a quadratic formula no matter what. So as you can see, we need to first put this equation in a standard form. So I'm going to have x squared, and I'm going to take this 5 to the other, so it's going to be minus 5x, and then this one was already positive there, which is equal to 0. So there is no way that there is factors of 3 that when we minus or plus is going to give us negative 5. So I'm going to make use of our quadratic formula, which is as follows. So our A here is 1 and our B is negative 5. Our C is 3. So let's just substitute, because there is a mark for substitution. So I'm going to have negative 5 plus or minus the square, and then B is negative 5. Square minus 4a is 1, and then c is 3, as you can see there, which is divided by 2. Oh, this is 2a then. So a is 1, just like that. And then for x, let's just check out the marks. There's mark for substitution, and okay, let's just can we simplify this up? But there is no need, because the answer is going to give us 2 marks there. So what we can do here, you can just punch all this in your calculator. If you punch, the first answer is going to be 4,30, or the other's x is going to be 0,7. This one give you 0,69, which when you round it into 2 decimal places is going to be 0,70. Just be careful when you're dealing with this one. So with this, we just took that kind of 4 marks, because 1 mark is for standard form and the second one is for substitution. The other 2 marks is for the final answer. Let's move on to the next. The third question is this one, which this is an inequality. So a common method I saw in a lot of my students, that some students will do this question like this. They say x minus 1 is equals to 12, or x minus 5 is equal to 12, something like this, which is incorrect. We only do those kinds of stuff when we have 0 at the end. And also don't forget that we have an inequality there. What can we do? So we need to first distribute these brackets out there. X multiplied by x is going to be x squared, minus x minus 5 is going to be minus 5x. The negative 1 is going to be minus x, and then this is going to give me positive 5, which is less than 12, just like that. Then from here on, what can I do? I can group the like terms. Negative 5, negative 1 is going to give me negative 6x, and then plus 5. I can take this 12 to the other side, it's going to be minus 12. Look at how I keep that one the same, the inequality the same. So I'm going to have x squared, and then minus 6x, and 5 minus 12 is going to give you minus 7, which is greater than 0. And then now I need to find the factors, which is going to be x. The factors of 7, that is going to give me 6. It's going to be 7 and 1. So it's going to be 7 and 1. So this is going to be negative and positive. So now I just need to say CV, which I'm going to just tell them the critical point. So my critical point is going to be x, which is equals to 7, or x, which is going to be equals to negative 1. Perfect. But remember, this is an inequality. We need to show our answer graphically. So what I do, there's a different method on this. Some other people use that one of, I don't know, something like this where you show, but for me I use the graph because I understand mostly the quadratic. So the quadratic we're going to make use of here is going to be this one that is here. We're going to make use of this to answer that kind of equation. So if you don't know, guys, this is a parabola. So we have negative 1 and 7 over here, and then this parabola, just because code is positive, is going to be a smiling graph. So where will be this graph be negative? Because less than, it means negative. Where will it be negative? Let me just make you realize. If you understand that other method, you can do it. But if you don't know, let me just introduce you this method, which is very easy. So these are the x value, these are the y value. Where are the y values? The y values are negative here. So the y values that are going to be negative on this side. Let me just try to remove this so it can be able to be a little bit understandable. They're going to be always positive on this, on the middle, because at the up, okay, let me just show you with this graph here. When we check the y values of any graph, that is a smiling graph, the positive side is this one. The y values are positive there, and then the negative side, remember, here we have the negative, we have the positive, these are the negative. So always, whenever we have a smiling graph, where it will be negative is always downwardsly here, So bear in mind, you can also use the other method here if you don't understand this. So where does it find? It found between negative 1 and 7. So it's going to be, we're going to put x here, and we'll put those things here, and we'll put negative 1 and 7, So this is the answer for this inequality question. Let's move on to the next. So 1.4 says that 2x, this is an exponential question actually, which is worth 4 marks. How can we solve this one? So to solve this, I think this one is very, very easy. What we need is just to first break this one down there. So I'm going to have 2x plus 2x multiplied by, let me just put multiply by 2 over 2, which is equals to 40. So if you pay to attention, we have a common factor here, which is 2x, so we can take it out, 2x. And if we take it on the first term, we're going to be left with 1, plus if we take it on the second term, we're going to be left with 2x point 4, which is 4. This one, if you punch it in the calculator, we're going to get 4, which is going to be equals to 40. So 2x is equals to 5, which is equals to 40. And then we can divide both sides by 5. And then 2x is going to be equals to, if you divide this, we're going to get 8, actually. So this is going to be 2x, and then you need to change this into a prime base, which is going to be 2 exponent 3. Exponent 3, actually. Good. Then we're going to have, since the bases are the same, now we're going to equate the exponents. So we're going to equate this and this, we equal it into each other, which is going to be equals to 3. So this is going to be the value of x for this question. Let's move on to 1.1. So 1.1.5, they also say solve for x. So this is a square root equation, guys. So on a square root, I have lessons on this for grade 11s. What we do here, you need to understand the marks allocation of this always. The first mark that you're going to find is for isolation. You need to isolate. What do I mean by isolation? You need to put the square root on its sides, and the number does not have a square root on the other side. There is a mark for doing that in this question. Also, for example, you're going to be left with 10 minus x squared, which are going to take all this to the other side. So negative x squared is going to be positive here. This is going to be negative 2. So this is what we call isolation. So next, you just need to square both sides to just remove the square root, just like that. Then if we square, we're going to cancel this one here. We're going to be left with 10 minus x squared, which is going to be equals to x minus 2 and x minus 2 over there. So 10 minus x squared. This one I'm going to do it a little bit fast. So this is going to be x squared minus 4x plus 4. This one, if you distribute this one, I'm going to get that one. I hope by now we're in grade 12, guys. You cannot fail to understand the distribution there. So from here on, we need to group the like terms, or we need to put this equation in a standard form. So I'm going to take this to the other side, I mean here, perfect. Also, I'm going to start with this. I'm going to start with x squared, and then I take this one to the other side. It's going to be positive x squared. And I'm going to have negative 4x, and then plus 4 is already there. I'm going to take this 10 to the other side. It's going to be minus 10, which is equal to 0 over there. Perfect. So from here on, x plus x is going to give me 2x squared minus 4x. 4 minus 10. 4 minus 10 is going to give you negative 6, which is going to be equal to 0. And then now, can we use I hate using a quadratic form. Let me just divide both sides by 2 by 2. X squared, this is going to be minus 2x. And then this is going to be minus 3, which is equal to 0. Yeah, I think this one is going to give us the factors that we're looking for. So the factors of 3 is going to be 3 and 1 here, which is negative and positive, obviously. So x and x. So x is going to be equals to 3, or x is going to be equals to negative 1. That's all. Perfect. So remember, a square root equation, each and every time, there's always going to be the answer that is not correct here. So you need to test these things out, So how do you test it? You're going to just take this 3, you substitute it here and also there, and find the one that is going to give you 0 is going to be correct. So if you substitute all these two answers, you will find out there that x is the only valid answer, which is 3. 3 is the only value of x that is going to give you 0, but however, x, negative 1 does not give you 1, that one. So we need to reject this one. It cannot be equal to negative 1. So with this, you're going to just successfully take these 5 marks. Let's move on to the next question. So our next question is 1.2, which is the simultaneous equation. So they say, solve for the x and y. Hopefully, I hope everyone understands this. What we need to do is to name this equation. I'm going to call this one equation 1, this one equation 2, So now I just need to make equation 3. I just need to pick one equation that it seems a little bit easy for me to make x or y subject to the formula. So that kind of equation is going to be this one. So I'm going to make equation 3 with that one. So I'm going to just take x to the other side. I'm going to have y, which is equals to, I'm going to take this x to the other side. It's going to be x positive. So here I already have positive. So I'm going to just have that positive 2, So this is going to be my equation 3. Some other people, they do this in different ways, but I prefer to do it in this way, So once you have equation 3, you're going to sub equation 3 into the equation that you have not yet used, which is equation 2 over there, So from here on x squared, on squared, I'm going to just, whenever there is y, I'm going to substitute this. Simultaneous equation can be a little bit tricky because these questions are, okay. So where's my equation 2? My equation 2 says that x squared plus 2x. So whenever there is y, I'm going to substitute x plus 2 minus 4, which is equal to 0. So here I have x squared plus, so 2 multiplied by 2 is going to give me 2x multiplied by x is going to give me 2x squared, and then 2x multiplied by 2 is going to give me 4x minus 4, which is equal to 0. So this is going to give me 3x squared plus 4x minus 4, which is equal to 0. So look at this. There is no way that we can find the factors here because we don't have a coefficient of 1. What do we do? So let me just give you a quick cheat formula actually to move on from this. So in your exam, you're going to be given an answer sheet, and that kind of an answer sheet, each and every question, they're going to give you some few lines to solve a question. So if you want to use your quadratic formula, it's going to be more long, it's going to be long, and then you're going to just like feel like as if like this thing is complicated. But what you can do here, you can use your quadratic formula to find the values of x and come here and pretend as if like you didn't use the quadratic formula. What do I mean? If you use a quadratic formula on this equation there, you will find out that the first value of x there, I don't know if you put positive or negative, you're going to get 2 over 3. The other one is going to be x, which is going to be negative 2, So after finding this, what you can do, we're going to open brackets here and just try to reverse those factors that you find there, because you already know the final answer is going to be x, which is going to be 2 over 3, or x, which is going to be equals to negative 2. So here you just need to pretend, just reverse those kinds of stuff, use a quadratic formula and write your answers down and just reverse those kinds of numbers as factors, So for this one, let me just demonstrate this one. So for this one, what you can do, just take this 3 that is downwardsly there and put it here and put x on it. And then this one, since it's positive, this 2, change it into negative 2, just like that, because if we have 3x minus 2, which is equal to 0, what we can do, we're going to just say 3x, which is going to be equals to 2, and we divide both sides by 3, and x is going to be 2 over 3, which is like that, perfect. So this is a good way to just save your time in your exam, but if you prefer to do that other one, you can do it, perfect. So from here on, this one, as you can see, this is an x minus 2. It's easy, it's going to be x, and then you change the sign, it's going to be plus 2. So when we bring it out, it's going to give us what we want. So we did find the values of x. We need the values of y right now. So I'm going to say sub x into equation 3, Equation 3, we have y, which is equals to x plus 2, or y, which is equals to x plus 2. Why do I say or? It's because we have two answers. So whenever there is x, we're going to substitute this first one, which is 2 over 3 plus 2. Or also on the other side, you're going to substitute this negative 2 plus 2. So y of the first one, if you find it, we're going to get 8 over 3. The second one is going to give you y, which is going to be equal to 0. So guys, let me just tell you a story. During my high school journey, whenever I was writing any exam, when I get a strange number like 0 or fractions, I panic a lot. I don't know why, but this kind of numbers, where you get 0, you'll be like, wow, is this correct? Like you will recheck it over and over and over and over again. It's a little bit strange to find this type of numbers in an exam, So yeah. This is how we solve this one. Let's move on to the next question. So now let's move on to 1.3. So guys, each and every question paper, whenever it comes to 1.3 is always those kinds of questions that are hard. A lot of students always skip, So yeah, so 1.3, there's a given f of x, which is equals to x, open blah, 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 and g of x, where a cannot be 0 and b cannot be 0, So they say if, look at this, man. They say if x minus a is a factor of f of x and x minus b is a factor of g of x, prove that d minus 1 is equals to 4a squared. So what is happening here, which is worth 5 marks actually? What is happening here? So here you need to, in order for you to understand this question, how am I going to solve it, you need to know a lot about calculus and understanding the factors. What do we mean by a factor, So if you are having trouble with this type of stuff, let me just give you a best recommendation ever. Go to the description box of this video, just scroll back there. There is a guideline, which is a Kevin Smith guideline, for grade 12. Download that kind of a guideline and then open page 134. There is 2 examples that it talks about that are a little bit similar to this one. Go and do those kinds of 2 questions by yourself. There's some memorandum that you can be able to see. After doing that kind of questions, come back and try to pause this video and do it by yourself. This is going to completely change how you view calculus actually and how you view this type of questions. That's just a recommendation. But if you already know this, let me just quickly solve this question. So what do we know about the factor? We know that if x minus a is a factor of f of x, we know that x is going to be equals to a, because if we have, for example, if we have x minus 2, which is a factor, x is going to be equals to 2, just like that, perfect. And if we know that x minus b is a factor of g of x, it means that x also on the other side is equals to b, but whenever we talk about factors, we know that if this is a factor, it means that f of a is going to be equal to 0, because if any number is going to be a factor, when we substitute it on the original equation, we always get 0. You can pause that and try to replay it again. Also on this one, this one's g of x, so it's going to be g of x, which is b. If we substitute b there, just because it's a factor, we have to get what? 0 at the end of the day, perfect. So let's substitute a on this equation and just let it be equal to 0. So we're going to have, whenever there is x, we're going to put a, so here there is x, we're going to put a, open brackets, and then we also substitute a plus a, which is minus b, then it's equal to what? To 0, just like that. And then from here on, you can see that we have a, which is 2a minus b, which is equal to 0. And then this is the same as 2a squared minus b, which is equal to 0. Perfect. Where are we going? Let's just try to substitute on the other side and see where we're going actually. So from here on, we're going to substitute b in terms of x on this equation also. So we're going to have 2, which is b squared minus b minus d. Whenever there is x, we're going to substitute b, which is equal to 0. So this is going to give us 2b squared minus b minus db, which is equal to 0. So look at this. What do they want us to prove? They want us to prove that d minus 1 is equals to 4a squared. How can we achieve that? So if you can pay close attention here, if we can be able to make b subject of the formula and also make b subject of the formula, we can be left with this d and also something like a squared. So then we can be able to see where we're going. So let's just make b subject of the formula. So this is going to be 2a squared. If you simplify this, we're going to get, okay, let me just try to, because these are not numbers out, let me just try to detail a little bit and divide by b and negative b, and b is going to be equals to, negative 1, guys, sorry, not negative b, negative 1, both sides, and then b is going to be 2a squared. But those who see this, they already know what I've done there. So we also need to make b subject of the formula on the other side. So here you need to be very, very careful. You need to know, you need to see where we're going. So we need d to be minus 1. So let's just take d to the other side. So you're going to be left with 2b squared. And then we take this one to the other side. It's going to be positive d. And then, oh, yeah, I made a mistake. Look at this, guys. This is positive. This is positive now. Yeah, good. And then this is db. I took that kind of a d and then to the other side. And then I'm going to take this b to the other side. It's going to be minus b, just like that. And then from here on, I'm going to have 2b squared. Here I can take a common factor, which is b. And I'm going to be left with d minus 1. Look at that kind of a d minus 1, where it comes from. It comes from here. So we're a little bit close from where we're going. So we need to make b subject of the formula. How can we do so? So we can divide both sides. Okay, let me just try to detail this. This is the same as 2 multiplied by b multiplied by b, which is equals to b over d minus 1. So here I can divide both sides by 2b. Divide both sides by 2b. So this is going to cancel this, and then 2, there's going to be left with b, and then also this b is going to cancel that other b. So we're going to be left with b, which is equals to d minus 1 divided by what? Divided by 2, just like that, So we have equation 1 and we have equation 2 there. So let's just equate this. So this is going to be 2a squared, which is equals to d minus 1 divided by 2. And then now we can be able to cross multiply this. So what do we need? Let's just cross multiply. Let's just start with this first. And then this is going to be d minus 1, which is equals to this. We'll multiply with this. Is going to give you 4a squared. And if you pay close attention, this is what they wanted us to prove over here. So this is how we solve this one, and we take these 5 marks. Okay guys, so if you're watching this video right now, I just want to notify you some certain features that just like appeared on my YouTube channel. Now you can be able to, like, while you're watching this video, for example, if it is this video right now, so if you find it useful, like it is helping you a lot, what you can do, you can also contribute. Like, you can press this thanks button thing here and contribute what you can if you find this video useful right now. So I'll be very grateful guys if you can contribute what you can, because right now on this YouTube channel I don't earn anything. I just like create bunch of videos, so it will really help me out guys to just see the effort. I will really appreciate it so much. So yeah, let's get back to the video. So now let's move on to question 2. So question 2, it carries 24 marks. Let's quickly start with 2.1. So 2.1, they say the 19th term of an arithmetic sequence is 11, while the 31st term is 5. Determine the first 3 terms of the sequence. So you need to understand what we're given here. We're given term number 19, that it is equals to 11, and we're also given term number 31, that this is equals to 5, you know. So how can we find the first 3 terms? In order for us to find the first 3 terms, we need to have a general formula actual, or Tnth, or the nth term actual. How can we find the nth term? We can make use of our simultaneous equation also, like this. Since we know that our formula is Tn, which is equals to a plus n minus 1, which has a difference just like that. So we know that term number 19 is equals to 11. So we're going to substitute 11 here, and a plus term number 11. Remember, n stands for a term number. So we're going to put 19 here minus 1, which has difference there, you know. So now we can be able to simplify this. We're going to have a plus 18 d, just like that. Then we can make a subject of the formula. So I'm going to just say a is equals to 11 minus 18d, just like that. So we can call this one equation 1. We need to do the same thing on the other side. We already know that this is going to be our formula. So on the nth term, we're going to substitute 5, which a plus, and then on our n, we're going to substitute this 31 minus 1 difference. And then we're going to have 5, which is equals to a plus 30. Is it correct? Is it 30? Yeah, 30 difference. And then we're going to take this 30 to the other side. So a is going to be equals to 5 minus 30d. So this is going to be equation 2. So both of these equations are equals to a. So we can equate equation 1 and equal it into equation 2. So equation 1 is what? Is 11 minus 18d, which is going to be equals to 5 minus 30d. You know, so we can group the like terms here. What I like to do, we're going to just say 18d. Take this 30 is going to be positive 30d here, and then take this 11 to the other side, you know. So negative 18 plus 30 is going to give you 12d, which is going to be equals to 5 minus 11 is going to, 5 minus 11 is negative 6 actually. So we're going to divide both sides by 12, divide both sides by 12. This is going to cancel this, and then d is going to be equals to negative 1 over 2. So we did find the value of d. Now we're looking for the value of a. So for the value of a, we can take anything that we like. What can we take? Let's just take this one actually. So we're going to substitute d there. So we're going to have a, which is going to be equals to 5 minus 30. We substitute negative 1 over 2. If you punch this in a calculator, you're going to get that your a is going to be equals to 20. You know, perfect. So what do we have here? We do now have the Tn, which is equal to a is 20 plus n minus 1. Our difference is negative 1 over 2. So we can find term number 1, and okay, term number 1 is a. Term number 1, we did find the term number 1 is a. Let me just try to erase this. So a, we do our term number 1 is 20. So to find term number 2, we're just going to substitute 2 there. which is minus 1, and look what I'm doing, which is minus 1 over 2. So this is going to give you a strange number. When I punched this in the calculator, I was a little bit anxious. So this is going to be 39 over 2. So term number 2 is 39 over 2. And I'm going to do the same thing for term number 3. We're going to substitute 3 there. So for term number 3, you're going to get what? You're going to get 19 as your term number 3. So those are the first 3 terms of the sequence. Let's move on to 2.1.2. So 2.1.2, they say determine the general term of the sequence. So we already have the general term there. If you've forgotten, here's a general term. It's Tn, which is equals to 20 plus n minus 1, and we have 1 over 2. We just need to simplify it a little bit further. So we're going to have 20. So n multiplied by that, this is negative, no? So this is going to be negative 1 over 2n. Then this is going to be positive 1 over 2. And what I like to start with this 1 over 2n and then group these like terms. 20 plus 1 over 2, what will it be? It's going to be 41 divided by 2, so it's going to be plus 41 over 2. So this is the general term of what? Of the sequence. Yeah. So we can move on to the next. They say calculate the sum of 81 terms. So we already have the difference, we already have the number of terms and all those kinds of stuff. So we can just make use of our formula. So we know that the sum formula is as follows, just like that. So we're looking for the sum of 81 terms. So the number of terms is going to be 81 divided by 2. And then the first term is 20 plus the number of terms is 81 minus 1. The difference, don't forget, is negative 1 over 2. Forget this negative, you're going to get it wrong. So if you punch this in your calculator, surprise, surprise, you're going to get 0. I was also amazed as you. But remember, a sum is the addition of all the terms. Yeah, it can give you the 0. But yeah, this is it for this answer. Let's move on to the next. So let's move on to 2.2, which is, they say, given the quadratic pattern, which is 2, 4, 10, 17, and 26. They say write down the next 2 terms. Like on this kind of questions of saying they want the next 2 terms, I like to do, like to find it on the other, let's say on the question paper, instead of me writing how I find, because here they just need the next 2 terms only for these 2 marks that is here. They just need you to mention those kinds of stuff, So you can do it whatever you want. By the end of the day, 2.1.1, your answers are going to be 37 and 50, and 50. Because this is what they only need there. How did you find it? They didn't want to see it on this question. That's why I don't want to spend more time. So 2.2, they say show that Tn is equals to n squared plus 1 is the general term of the quadratic pattern, which is worth 4 marks. So yeah, that's where we need to just demonstrate how we can move on forward. So 5 minus 2 is going to give you 3, and then 10 minus this is going to give you 5, this is going to give you 7, this is going to give you 9. And then going forward, this is going to give you 2, obviously, and then this one's going to give you 2 and 2, So to find those kinds of values, we just need to say 2a is going to be equals to this one, which is 2. And if we divide both sides by 2a, is going to be equals to what? To 1. And for b, we say 3a plus b is going to be equals to this number, which is 3. And then 3a is 1 plus b, which is equals to 3. b is going to be 3 minus 3. b is equal to 0. Oh, okay, cool. That's correct. And then for c, we say a plus b plus c is going to be equals to this number, which is 2. a is 1 plus b is 0 plus c is what we're looking for, which is 2. And then c is going to be equals to 2 minus 1. And c is going to be equals to 1, So Tn is going to be equals to a is n squared, and plus 1. Actually, we're just proving this actually because b is equal to 0, just like that. Let's move on to the next question. So the next question, they say determine the term of the pattern that has the value of 209. So we have Tn, which is equals to n squared plus 1, n squared plus 1, just like that. Yeah, it's correct, it's plus 1. So they want the term that is equals to 219. So they need the number of term that is equals to 290. So going to just substitute 290 over here, which is going to be equals to n squared plus 1. And I'm going to take it to the other side. So I'm going to have n squared plus 1 minus 290, which is going to be equal to 0. And n squared, 1 minus 290, is going to give us minus 289. 89, this is 89, which is equal to 0. So this is a difference of squares, so I'm going to open two brackets just like this, which is equal to 0. We'll put n down, and we're going to look for the square root of 289, which is going to be equals to 17, and we'll put it here and here. This is a difference of squares, so negative and positive. And n is going to be equals to 17, or n is going to be equals to negative 17, but it cannot be equals to negative 17 because the number of terms can never be negative. So therefore n is equals to 17. Perfect. So moving on to 2.2.4, they say between which two consecutive terms of a quadratic pattern will the first difference be 25? So what is happening here? Look at this. So they say they want two consecutive terms. Consecutive, that means the terms that are following each other. For example, 2 and 3. These are the consecutive terms because this is 2 and they're following each other there, So they want two terms on the quadratic pattern that the difference of it is going to give you 25. For example, let me just give you an example. Since we have the first terms here, and then we have something like this, and then we have, it can be, for example, it can be 50 and 25, whereby when we say, it can be like 25 and 50, such that when we say 50 minus it's going to give us 20. I'm just giving an example, but this number must be here. It must be a quadratic pattern. So in other words, this one is an arithmetic pattern, perfect. So in order for us to find those two numbers that when we subtract them together give us 25, what we need to do, we need to understand which term number is 25 on the arithmetic pattern that is there. Why do we need to understand that? It's because of this. We've got term number 1 and term number 2 and term number 3 of a quadratic pattern. If we want, for example, term number 1 of an arithmetic pattern, it is found when we take term number 2, we subtract with term number 1, we find term number 1 of a quadratic, of an arithmetic. Okay, let me just try to illustrate with this example that is here. So look at this. To find this term number 1, we take term number 2 and term number 1. We say 5 minus 2, it gives us term number 1 of a quadratic pattern. And also to find this term here, we take this and we subtract with this. Why am I telling you this? It's because, first of all, we need to understand if we can be able to find out which term number is 25 on this pattern. If we can be able, let's say for example it is term number 17, 25 is equal to term number 17. So we know that T17 of an arithmetic pattern, at the top there is going to be formed by term number 17 and term number 18 of the quadratic pattern, Hence I'm showing you with this. In order for us to achieve this, we take term number 2 and term number 1 to get term number 1 there, So also, if 25 is term number 17, it means on the quadratic pattern, It's going to be term number 17 and term number 18 that give us this term number 17. Perfect. So in order for us to find those kinds of two consecutive terms, we need to understand which term number is 25 on this pattern that is here. So we have them. We have what? We have, let me just try come here. We have on the second difference, we have 3 and 5 and 7, and we have 2 and 2, So our arithmetic part is going to be, the first term is 3 plus n minus 1, which is the difference is 2, just like that, Perfect. So we need to understand which, since here they say the difference is going to be 25. So we need to understand which term number is equal to 25. So we're going to find that kind of term number is equal to 25 plus n minus 1. We're going to find it out here. So what I like to do, I solve these things in this way. I think this one is the easiest one for me. And I divide both sides by 2. This is going to cancel this. If you punch this in your calculator, you're going to get 11, which is equals to n minus 1. And then 11 plus 1 is going to be equals to n, and n is going to be equals to 12. So look at this, look at this, look at this. Term number 12 is equals to what? To 25. In order for us to achieve term number 12, we need term number 12 on the quadratic and also term number 13. That's what I was just trying to tell you there, Perfect. So those kinds of two consecutive terms that give us 25 are term number 12 and term number 13 of a quadratic pattern. Perfect. So we're going to find it out because we know that our quadratic pattern, the equation is going to be is what? Is Tn is equals to n squared plus 1. So term number 12 of a quadratic is going to be 12 here squared plus 1, which is going to give you 145. And then term number 13 is going to be 13 squared plus 1, which is going to give you 170. And look at this, it makes sense. Look at this, it makes sense. Term number 12 is 145. Term number 13 is 170. And when we subtract these two, it does give us 25. So those kinds of two consecutive terms that they are looking for are term number 12 and term number 13 of a quadratic pattern. I hope this explanation helps you to understand this question. So now let's move on to question 3. So question 3, it carries a minimum of 15 marks. So let's just quickly start with 3.1. So this question, it reads as follows. Square A has sides 2 centimeters each. Square A, they mean this one. So here, in other words, they say we have 2 centimeters on this one. And they said the length of side of square A is half the length of the sides of square B. What is this? So the length of square A, they say it's a half the length of square B. What is the length of square A? They told us that is 2, which is going to be half B. Then when we divide both sides by 1 over 2, 1 over 2, find out B is the same as 4. So this one is 4 centimeters each side. It's 4. Perfect. Yeah. So let's move on to the next. They say also, now we're coming to what they say, and the length of the side of square C is double the length of the sides of B. So look at this. The length of side of square C is double, which is 2, is twice the length of square B. So what is the length of square B? Is 4, which is the same as what? As 8. So this one is 8 centimeters each. It means also, yes, 8 centimeters. Look what I'm doing. Okay, good. I will not write inside there because this will make this cancel. So, okay. The first question, they say, determine the length of each diagonal of a square. So you need to understand that the diagonal lines of a square like this. Okay, a square, there's 90 degrees here and the diagonal lines are equal, so if you find one, then we have successfully find the rest. So how can we find the diagonals of this one? If here is 2 and here is 2, we can use the theorem of Pythagoras because we have 90 degrees there. So just because of 2 marks, we'll not detail that mark, just like get straight to the point and just like use the quadrat the theorem of Pythagoras. Yeah, square. So this is the theorem of pi. I think this is unnecessary, but yeah, r is what we are looking for, and then the x and y is going to be 2 square plus 2 square. Then we're going to square both sides, and then r is going to be, if you punch this on a calculator, you're going to get 2 root 2, perfect. So the 3.2, they say calculate the area of square C. So guys, I have playlist in measurement for grade 10 whereby I told you how to find the area of a square. If you don't know, the area of a square, or for this one square C, is going to be equal to the length multiplied by length, So the length of this one is 8, so 8 multiplied by 8, which is going to give you, if you punch this up, we're going to get 64 what? Centimeter square, just like that, because we are looking for the area. So let's move on to the next questions. So to save time, I just like make sure that I've written absolutely everything there. They say show that the sum of the areas of the first 10 square is 1 3. Oh, that number is huge. This one, 1,03,980, 100 something like that. Okay, good. So they want us to show that the sum of the areas of the first 10 squares, so we can make a pattern using the first three one. So we just found out on our previous question that this one, the area of it is 64 centimeters square, so we need to find this one. So to find this one, we know we're going to find for B, area of B is going to be 4 multiplied by 4, which is going to give you 16. For this one, for area of A, is going to be 2 multiplied by 2, which is going to give you 4, So let's just take a look at the pattern that we have here. Term number 1 is going to be 4. Term number 2, 16. Term number 3, 64. So this is going to help us to build up the pattern that we're going to just use to figure out the next areas, So this the pattern that will form is for the areas for the first 3 squares. So we can find a difference. 16 divided by 4 is going to be 4. 64 divided by 4 is going to be 4, perfect. So they need the sum, So we know that the sum of an arithmetic is as follows, whereby A is the first term, N is the number of terms, and then R is the difference. We already have R is the common ratio, not the difference, So they need the sum of what? Of 10 squares. So we're going to say sum of 10 is going to be, the first term is 4 over R is 4, and then how many? 10 minus 1 divided by 4 minus 1. So if you punch all this in your calculator, you're going to get 1398100, just like that. Let's move on to the next question. So the next question, they say show that the length of each diagonal of the nth square is root 2 and 2. Okay, is this thing that is here actually, in short. So what you must understand here, by just looking at this, if you can pay attention, you can see, if you have been in this game for a long period of time, you can see that this is the same as ARN minus 1, This N that is there, I think it comes from here, and then this R, I think is the difference, and then this one, I think is the first term, actually, yeah. Okay, so they want us to show that the length of each diagonal, of the square that are going to be there in future. The next one is going to be someone there, and then up until there, it's going to be a square root of 2 and 2n there. So we need to find the diagonals. Remember, this one is 4, and then this one is 8. So to find the diagonals, we just make use of our quadratic equation. So for this one, if you use your quadratic on this one, I'm just going to just say r squared is equals to 4 squared plus 4 squared, which is going to give you 4 root 2. The next one, when you square both sides, the next one also is going to give you 8 square plus 8 square is going to give you 8 root square 2. So this one is 4 root 2, and then this one is 8 root 2, just like that. So we can see the pattern there, and then we can find the difference and try to see the nth term of this, yes. So what can we form here? So we can find the difference, we can find the R. Why do I keep saying difference? It's ratio. We can find the ratio. We know that to find the ratio, we have to take term number 2, we divide it with term number 1, So what is our term number 2 here is 4 root 2, which we need to divide by 2 root 2, So if you pay close attention to this is going to cancel this, and then 4 divided by 2 is going to give you 2. So R is what? Is 2. So we're going to have Tn, which is going to be equals to A is 2 root 2, and then what is R? R, when we write R, is 2, and then we have N minus 1, So how did they come up with this N that is alone there, and then how did they eliminate that kind of a 2? In order for you to understand that, you need to be able to understand that this is the same as 2 root 2. We can expand this like this, 2n multiplied by 2 negative 1. We didn't change anything. We just use, since we know when we have, for example, we have x plus, or on the exponents, this is the same as 2x multiplied by 2, multiplied by 2 exponent 1. This is what we've probably done there. Nothing that is fancy that we've done, So this is going to be 2 root 2, and then multiplied by 2n. You know that this, from calculus, 2 squared, this is the same as multiplied by 1 over 2, just like that. So if you pay attention, allow me to finish this here so that I can be able to demonstrate. So this is going to be 2 root 2 multiplied by 2. Look at what I'm doing, guys. This pen is tired. It's like me. So this is the same as 2, like that multiplied by 1. That this fraction, we can just divide it just like this, and then that kind of a 2 can go downwards later because we have a fraction there. Perfect. So from here on, look at this. This 2 is going to cancel out with this, and then our Tn is going to be square root of 2, which we're going to be left with what? With 2, which has an n over there, Try to pause and try to replay this part. This is the same as if, for example, if we have, you need to understand that when we have x over 2, this is the same as 1 over 2x. If you understand this, then that one is going to make sense how I done it, Perfect. Let's move on to the last question. They say determine the square which has a diagonal 256 root 2 centimeter. So we have squares there. So they want the one which square, because we have square number 1, which is square A, square B, square C, actually, Yeah. So which square is going to be this one? Since they talk about letters, okay, yeah, let's just do it like this. Since we know that the Tn, using our previous question, is the same as root 2 over 2n. We've proven this in our previous question, 2n, just like this. So when the number of terms is going to be equal to that one, so I'm going to just substitute 256 root 2 here, and I'm going to have root 2n, and I'm going to divide both sides by 2, divide both sides by root 2. This is going to cancel this, and this is going to cancel this. 256 is going to be equals to 2n, and then if you change this into a prime base, you're going to get 2 exponent 8, which is 2, and that one of pressing this number equals sign shift and press fact. So n is going to be equals to 8. So which term is equals to, like which letter actually is equals to 8? Or maybe we can say, okay, let me just count. A, B, C, D, E, F, G, H. Okay, A, B, C, D, E, F, G, H. So a square number H, a square H is equal to what? Is equals to, it has a diagonal of 2, 5, 6 root 2. Yeah, a square H, or you can say number 8, square number 8 actually, or maybe you can, because the reason why I use the letters is because they use the letters there called square A, square B, square C. So the eighth one is going to be square H, just like that. So yeah, let's move on to the next questions. Okay guys, so I just want to plug you into some certain feature that is on my channel right now. So if you want more videos, or you want to have early access to my videos on this channel, what you can do, like videos like this, let me just show you. If you go to videos, to go to the members only, you'll find videos like this. So when you want to join, you can become a member by pressing that kind of a button over there. So on this one, before you join the membership, there's two levels. The first one is level 1, which is you can pay 30 rand per month actually for being a member over here. So on becoming a member with level 1, you get access to my videos before I release them, early videos, and also get chance to like ask me some questions the way I'm going to like reply publicly. But on level 2 guys, you get to see all these videos just like this. For example, let me just show you another one, which is, if you go scroll down over there, you see this type of videos. There's a lot of them actually, some question papers just like this, that if you become a member, you get access to all of this. So if you want to become a member, go to this and join, and click any level that you can be able to afford from this in this channel. You're going to benefit a lot from what I produce. So yeah, let's get back to the video. So now we are moving on to question 4. So question 4, it's functions. This is one of my favorite guys, because these are very, very, very easy. So this one carries 27 marks. Let me just quickly start with 4.1. So 4.1, they say in the sketch below, the graph of G, as we can see, point A and C are the x-intercept, and T is the turning point of G. Graph of F cuts are that one. We can see point E is symmetrical to point D on the graph of G. So I think that is going to be useful on our following questions, but for now, we can move on. So they say determine the coordinate of T, the turning point of, determine the coordinate of the turning point of T actually. So hopefully guys, if you're in grade 12, I hope you know that in order for us to find the turning point, we use this special formula, that is x, which is going to be equals to negative b over 2a, you know, whereby our a, we just use the same way that when we use a quadratic formula. B is going to be negative 3 over 2a is 1, and you can punch this in a calculator, we're going to get 3 over 2, just like that. So this is the x value of the turning point. We need the y value. To find the y value, we take this and substitute it on the original equation. How? Like this, I'm going to say g of 3 over 2. Whenever there is x on that equation, I'm going to just put 3 over 2. Let me show you. I mean like this, you know, perfect. So you can punch this in a calculator, which you're going to get a strange number, which is negative 49 over 4, just like that, you know. So now we did find the coordinate of T, which is going to be 3 over 2 and the negative 49 over 4, just like that. And they say 4.1.2, write down the range. So the range, guys, we talk about the existence of the graph on the y-axis. How far does the graph exist from the y-axis? Y-axis, I mean this line here. We check where does it start to exist and where does it end. So whenever we check this one, we just check what? We check the turning point, actually, the y value of the turning point. If we put a line here, we can see that this graph downwards here, it does not exist. It starts to exist from negative 49 over 4 up until where? Up until positive infinity. So for 4.1.2, we can say y is an element. Where does it start? It starts from this point. We talk about the y values, not the x values now. So that's from the negative 49 over 4 up until the positive infinity, which we're going to put it like this. How some other students, they like to do this one is like y is going to be, it exists from where y is greater than or equals to negative 49 over 4. So it's up to you. As you can see, it starts to exist where y is greater than negative 49 over 4. But I like that other one of pointing it like that, perfect. Anything that you prefer, you can do it there. So the last one, they say 4.1.2, determine the coordinate of C. So the coordinate of C is this one. What did they say about the coordinate of C here? They say A and C are the x-intercept. So how do we find the x-intercept? So we know to find the x-intercept, we need to let y be equal to 0. That's what we know. So where do we let y be equal to 0? On our original equation, our equation is x squared minus 3x minus 10. We're going to put equal to 0. And we're going to just find the factor. So the factors of 10 that is going to give us 3 is going to be 5 and 2. So this is going to be negative. This one is going to be positive, just like that. X is going to be 5, or x is going to be equals to negative 2. So between these two x-intercepts, which one is correct that fits the coordinate of C, guys? So if you pay attention, we have A, we have B, and C, we have A and C, it falls on the positive side, and then A is on the negative side of the x-axis, So here, C is going to be on the positive side. We're going to take this positive one. It's going to be 5 and 0, and then A is going to be negative 2 and 0. Let's move on to the next question. So our next question is 4.1.4. They say determine the equation of line BC. Where is line BC? And BC, they talk about this one that is there, So we already have 5 there. So this is just like the saying called like determine the equation of a straight line, because that's what we're going to do here actually, perfect. So how can we find that one? We know if we can be able to find the value of B, then we can find the gradient, or we can do it like this. The easiest way, I just discovered it right now. If we can be able to find the value of B, how can we find the value of B? The value of B, if you read the statement there, they say it is a y-intercept. So coordinate of B is going to be, since the y-intercept is this one, is going to be 0 and negative 10. So in other words, to our new equation, which is y mx plus c, our c here already have it, which is the y-intercept is going to be negative 10. So here we can write negative 10 just like that. So we can find the gradient by using the gradient formula, or the other way around. I just discovered it right now. We can substitute this point, this here, where there is x, we can put 5, where there is y, we can put 0. So we can put 0 here, where there is x, we can put 5, which is minus 10. And we can take this 10 to the other side. This is 5m. We can divide both sides by 2. 5, m is going to be equals to 2. So the equation is going to be y, which is equals to 2x minus 10. So this is the equation of what? Of BC. Let's move on to the next. 4.1.5, they say determine the coordinate of E if E is symmetrical to D. So what do they mean by symmetrical? They mean like the distance between, okay, let me just show it like this. They are on the same line like this, In other words, they share a common line that is there. They're symmetrical to each other. And also, if we cut this, let me just show you with this. If we cut this symmetrically to this kind of a line, the distance, let me show you this. The distance between this and also this, they are equal. That's what we know about the symmetrical of these two lines. And also, if they're symmetrical, look at this. They can also share the same coordinate, which is the y value of them. The y value of D is the same as the y value of E because they are on the same line, So E, in other words, the x value we don't know, but the y value is negative 6, just like that. So how can we find the x value there? If we can be able to find this point, which is the midpoint between these two, then we can be able to just split out the midpoint formula and find that kind of value of x. How can we find that kind of a midpoint? We know that this point that is going to be here is going to share the same coordinate as this. this midpoint that is going to be there is going to have the x value of 2/3. Why? Is because it's symmetrical to this, The y value is going to still be the same because it is found on this line. So the y value is going to be -6, just like that. So this is 3, it's 3/2, no? Yeah, it's 3/2. Let me just check. Yes, it's 3/2. Yeah, good. Perfect. So now that we have the midpoint of this, we can split the formula and find this value of E. Oh, and I just realized something. We can just substitute that kind of an x to the original equation. I didn't see that. Okay, let me just carry on with my method. Yeah, since now, this is the easiest one. But yeah, let me just do what I wanted to do here. So we can split that x value of the midpoint. So x of E plus x of D, divide by 2. Remember this whenever we're using a midpoint, if we have a midpoint and we're looking for this coordinate, we can always split. So the value that is going to be here is going to be this 3/2, and then x of E, which is plus x of D is -1. Let me just write -1 there, -1 divided by 2. Now I can cross multiply this. I can cross multiply this. Is going to be 2x of E minus 2, which is equals to 3 multiplied by 2 is going to give me 6. 2x of E is going to be equals to 6 plus 2, and then I'm going to divide both sides by 2. And then x of E, if you punch this in your calculator, this is the same as 8 divided by 2, which is going to give you 4. So this is going to give you 4, and therefore we can conclude that E is the same as 4 and -6, just like that. But you can do it by just, since we found this, you can just substitute this point to the original equation of f, and then we can be able to find that one. But even this one, it works. Let's just move on to the next question. So our next question is, this one is my favorite because a lot of people panic whenever they see this. So here they say, for which values of x will f of x greater than g of x? So what does this mean actually? Here they say they want the values of x where f is above g of x actually, So how can we find that kind of x value whereby f is above and g is below, In order for you to be able to find that kind of value, you need to interpret this graph. You don't need to calculate, you just need to interpret this graph that is here. How so? If you can be able to draw, I call this maqala in Tsonga. I don't know why, but yeah. When I learned this, my teacher taught me in this way. So whenever we have this kind of notation, what we do, we're going to draw the horizontal line like this, where these two graphs intersect. So they intersect at x, where it's equal to 0, and they also intersect where x is equal to 5. So this will make sense in a second, So if we can be able to draw the horizontal line where they intersect, now we're going to just interpret this graph. We're going to check where between this horizontal line, we're going to start with this part that is here, between this side here. Is this graph where between these two graphs, which one is above which here? Is f above g of f? So remember, f, let me just separate this. Okay, the green one is f, and the g of x is this yellow one, So we want to where, okay, let me just highlight also this. F is the green one, okay, g is this one, and then f is this one. So we want where f is above, So if we check between where x is less than 0, let me just use this. This side. If we check this side, we can just clearly see the yellow one, which is g, is the one that is above, and then what this f of x is below, the one that is above is the yellow one, But if we come between 0 and 5, we can clearly see that the green one here is the one that is above, and then the g is below, you know. In other words, the F here is above and G is below, you know. This is what we want. So this one, it qualifies, this one does not qualify. Let's move on and check the other one. So on this one, you can see that F is below and then G is above. We don't need this one. We need the one that where F is above and G is below. So which one is that one? So we're going to say is where we're going to put X here, and then it is in between, this found between 0 and 5. So we're going to start with the smaller number and then end with the last one. So this is our answer, you know. Perfect. Let's move on to the next question. So our next question, it is a 4.1.7, for which values of X where X squared minus 3X minus 10 be positive. Remember guys, this is what, this is G of X. Remember, this equation is the parabola, which is G. So this is like them saying, correct, give us the values of X where G of X is positive, where is greater than 0. In other words, they just like didn't want to come clean, but this is what they mean. They want the values of X where G of X is positive, where is greater than 0. So you might be asking yourself, great, well, how can we do it in that kind of way that you are doing it right now? So if you want the values of X where this graph is positive, we're going to draw our vertical lines right now on the x-intercept, because on the x-intercept, that's where we start to see the change of the graph. For example, from this point here, we can see that this graph start to be positive here, and there's going to start to be negative, you know. So we're going to draw our vertical lines where the change of the slope is starting to change there, you know. So we're going to draw our vertical line here and also here, you know. So I'm going to just interpret each and every horizontal line and just see where is our graph positive, you know. And when we talk about where our graph is positive, we don't look at the x values, we look at the y values that are positive, you know. The y values, I mean these, you know. So we know that the y values above here, they are positive, and above here they are negative. I hope you know that, you know. So if we start from this side here, we can see that this side, the graph is what is positive here, you know. So this one, it qualifies. This is what we want. We want where G of X is positive, you know. Perfect. So if we come between this is -2 and 5, you know, this middle one here, you know, we can see that from here, this graph, look at this, from this point to this here, the y values are negative here, all of them, you know. Perfect. So this is not what we want. We want where it is positive. This one does not qualify, you know. Perfect. We can move on to the next and keep searching on the other one. So when we go up here, we can see that it starts to be positive again. So we need this positivity. So this one, it also qualifies. So which values of X that where this graph is positive? It is from this -2 to there, and where X above them. So how can we say this? We're going to just say X where it is less than -2. All the values where X is less than -2, that's where this graph is positive. And also where X is what is greater than 5, you know, because all the values that are greater than 5, this graph is what is positive. And I hope this make you understand how to answer this question. Let's move on to the next one. So the next one, there's a given f of x, which is 2 and x plus 1. So this is an hyperbola graph, you know. Yes. So there's a write down the equation of the asymptote, you know. So when we look at the asymptote, we just look at the this and also this one that is here, you know. So as you can see, hopefully by now, I hope you guys, no one in grade 12, you are writing, you don't know how to answer this type of questions, guys. I hope you do understand this. So our x is going to be -1, and y, where is y? Is 0 there. We don't have that kind of horizontal line. Is 0, you know. Perfect. So they say, sketch the graph of f and show the intercept with the x's, you know. So we need to show the x-intercept and the y-intercept. So let's just find the x-intercept first. How can we find the x-intercept here? We need to let y be equal to 0. If we put 0 here, 2 over x plus 1. Oh, this will give us error, because this multiplied by this is going to give us 0. So it means that there is no x-intercept in this graph, yeah, there's no x-intercept. Okay, let's just look for the y-intercept. For y-intercept, we have to let x be equal to 0. We'll put 0 here plus 1, which this is going to give you 2, actually, because 2 divided by 1 is going to give you 2. So we did find the y-intercept. The coordinate is going to be 0 and 2. Yeah, I think, now we're done. We can be able to sketch this graph. Let me just use this one. Just like that. So what we can start from, we can start with our asymptote. So let me just draw the asymptote. So the asymptote is from -1. So I can draw it over here. So this is x, where is equals to -1. And this is y, where is equal to 0. But this one is unnecessary. So this is the x values. This is the y values, Some other people confuse this with that one. These are not the same, Here we are indicating the horizontal asymptote. So our point is going to be found over here. So if we draw this, it's going to be somewhere here, and then also on this side over there, so we just need to mention this point is 0 and 2. Yeah, and I hope for 3 marks we're going to take this one. Let's move on to the last question. So the last question, they say, if f is translated to g, the g of x is equals to 2, okay? Discuss the translation. Okay. Our f, it was like this, and it changed into this. What changed here? So in order for you to understand this, you need to understand this graphical. Let me just try to draw those kinds of two graphs. So the graph of f, initially, it was like this. We're having x, which is equals to -1. And our graph, it moves something like that. I don't want to focus on the x-intercept. It moves something like this. Here our y was equal to 0. This was the graph of f, actually, perfect. So they say it moves from this one. So if we have this one, what will happen to this graph of g? This is the y, this is the asymptote of, this is the horizontal asymptote, actually. It's going to be 2. So it's no longer going to be 0, it's going to be 2. So it's going to move from here to 2. So we're going to have, this one I'm going to color it with red. So this one's going to be 2. And then this one is going to move, since it's x minus 2, so it's going to be x, which is equal to 2. So this one is moved from -1. This was -1, guys. This was -1. Let me just try to erase this. Okay, so here we're having x, which is equals to -1. So but this one, it moves from x. If we use this one, it's going to be, look at what I'm doing. I want to do this with red, so that it can be understandable. So this is going to be x, which is equals to 2, perfect. So, okay, we're not interested today. Okay, let me just try to draw the kind of a graph. It's going to be somewhere here, for example, somewhere there. So they want you to tell them what happens. They want you to tell them the movement from this graph. So if you can pay close attention, this graph, it first shifted from 0 to 2. The first shift that we see here, it moves 2 unit upwards. So it moved, let me just write it like this. It moved 2 unit. What I'm doing, 2 units upwards. That's our first observation. And look at this. It moved from this asymptote, which was -1, and then to 2. So it moved to this point, which was -1, and then it goes to 0, it goes to 1, and it goes to 3. So it moved 1, 2, 3 unit. So it moved 3 unit. Let me just say moved 3 unit. Where? To the left, actually. It moved 3 unit to the left, just like that, So this is the translation of graph of G to the graph of F to the graph of G. Yeah. So this is it for this question. So now let's move on to question 5. So question 5 is an exponential question. So it is carrying 13 marks on it. Let me just quickly start with 5.1. The sketch below represents the graph of f, which intersects at y-axis at 1 and passes through the point 2 and 9. So this is the point that they're talking about, and also that one that passes through the graph of f. So they said show that the equation of f of x is equal to 3x. So what you must understand on this graph, you can see that there is no horizontal asymptote here. There is no horizontal asymptote. So it's equals to 0. Q automatically is going to be equal to 0. So we're going to be left with f of x, which is going to be equals to bx. So in order for us to find b, we need to substitute any point that is passing through that kind of graph, which we're going to substitute this one. So you're going to put 9 and b2, and then we're going to, let me just square root both sides just like this, and b is going to be equals to plus or negative the square root of 9, which b is going to be equals to 3, or b is going to be equals to negative 3, but b cannot be equals to negative 3. So therefore we can conclude that f of x is going to be equals to 3x, just like that. And then question 2, they say determine the equation of f. In other words, they want the inverse. So we know that the original equation is y, which is equals to 3x. In order for us to find the inverse, we need to interchange this like this, and after interchanging, we're going to just say y is equals to the log of what? Of this. You just copy this the way it is, you paste it here. Perfect. With that, we are done. Let's move on to the next question. This is sketch the graph of f. Show all the intercept. Actually, here we're looking, since we know that f of negative 1 of x is equals to a log 3x. I saw some student trying their best to find the x-intercept when you're given inverse. No, you cannot find it unless you understand the logs very well. But what you can rather do here, you can just interchange these 2 points here. For example, we have 2 and 9, and we also have 0 and 1. So what you can do, you can just interchange these points. This is going to be 9 and 2, and this is going to be 1 and 0. So remember, this is for f, this is for f, this is for the inverse, So with this, now you can be able to draw a graph, just like you don't need an x-intercept actually. So 1 is going to be somewhere here, and then 9 and 2 is going to be somewhere there. So the graph is going to be something like this. So this is going to be 1, this is going to be 9 and 2. And with this is how you're supposed to draw that kind of a graph that they're looking for. Let's move on to the next. To this question, this is one of my favorite questions. They say 5.4, given that the g of x is equals to 2x, calculate the value of p if p is equals to all this nonsense that is here, that trying to make sure that you don't get the total in this question, and it is worth 5 marks. So what you must understand the sigma notation here, that when we have a sigma notation, that number that is going to be here is the starting term. The number that is here is going to be the ending term. This is the ending term. And the number or anything that is going to be here is what we call the nth term, or the Tn of the pattern, So if you pay close attention to this question, P, before I move on, P here is going to be the, what do we call this? P is going to be the sum of those kinds of patterns that is going to be there, perfect. So in order for us to find those kinds of sum, we need to first find the first 3 terms of each, So we're going to start with f of x. So f of x is this one that is here, perfect. So in order for us to find the sum, we need to first find the first 3 terms. How do you find the first 3 terms? We're going to, if you don't see, let me just try to rewrite this. This is an x which is equals to negative 2 and 5, and f of x just is them. So from here on, in order for us to find, we need to start from negative 2. So we're going to substitute negative 2. Look what I'm doing. So we're going to substitute negative 2 to our graph, 3, negative 2. And then this, if you punch this in a calculator, you're going to get 1/9, just like that. And then for this is term number 1. For term number 2, and I also want to paint a picture on you. We know that these numbers, this is -2, this is -1, this is 0, this is 1, this is 2, and then there's -3. So the starting term that is here, we start from this number and we go forward, just as the same way, because I try to explain this question to my students, they don't understand. Look at this. If like there was an x which was equals to 3, we're going to start from 3 and we substitute 4 and substitute 5. So it means also here we're going to start from -2, we go on the other side. It's a little bit confusing because we're starting with a negative number. Hence a lot of people start from -2 and they go on the other side. So just be careful there so you cannot make any mistake. So the second term is going to be -1, which is 3 -1. This is going to give us 1/3. And then f of, we're going to put 0. This is going to give us 1 actually, So the first 3 term of f of x is going to be 1/9 and 1/3 and 1, So let's find the difference or the ratio. Yeah, we can see that this is going to be and geometric actually. 1/3 divided by this is going to give you 3, and also this one is going to give us 3. So r is going to be equals to this one, So we need the number of terms. If you understand number pattern, whenever we're given a sigma, we know that to look for the number of terms, you don't need to go far. What we just need to take the top number of the sigma, we subtract it with the bottom number, and we add 1. The top number is this 5 that is there, minus the bottom number, which is -2, and we add 1, just like that. So if you punch this in your calculator, you're going to get that this is equals to 8. So the number of terms is equal to 8, just like that. So with this, now we can be able to find the sum. We're looking for the sum of 8 terms of f of x. So going to say sum of 8 is going to, hopefully, I hope you know the formula, guys. The first term is going to be 1/9 over the difference is 3, and then term number 8, just like that, over 3 minus 1. So I'm just lazy to write the formula out there. So if you would take your calculator there and punch this, you're going to get a strange number. Like I don't want to round it into decimals. Let me just recheck it. Okay, so it's 32,8,0,9, just like that, perfect. So now we did find the sum of this one. Now we need to look for the sum of the other one, which the other one I think is easy because it's a straight line, so it's going to be very, very easy for us. So now we find the sum of that one. Now we need to look for this one. So this one starts from 1 actually. So we're going to just say g of 1. We substitute 1 there, minus 1. This is going to give you 1 actually, because 2 minus 1 is going to give us 1. And we'll go and substitute 2 minus 1. This is going to give you 3. And then g of 3, we substitute 3 over here. This is going to give you 5. So our pattern actually here is going to be 1, 3, and 5. So what is the difference actually? The difference is going to be 2, obviously. Good. So now we need to look for the number of terms. We know that the number of terms is equals to the top minus bottom plus 1. So the top number here is 10. Minus the bottom one is minus 1 plus 1, which is going to give you 10. So now we are looking for the sum of what? Of the first 10 terms, perfect. Let me just try to write the formula. So this is the formula for this one. So the number of terms is 10 divided by 2. 2a is 1. This is easy. Plus the number of terms is 10 minus 1. The difference is 2. Then bigger brackets, and if you punch this in your calculator, you're going to get 100. So now that we find all those kinds of sums between those kinds of, now it's time to find the value of p. P is equal to the sum of f minus the sum of g, so this is the sum of g, this is the sum of f, as you can see right now. So this one is give us 32 divided by 9, which are going to minus it with 100. So if you plug this in a calculator, we're going to get 20. Let me just good. So it's going to be 2380 divided by 9, perfect. So if you round this into two decimal places or into decimals, it's going to be 264,44, just like that, so this is the value of p. Actually, it's equals to this channel. Let's move on to the next question. So now let's move on to question 6. So question 6, it carries 21 marks. So this is calculus, guys, one of my favorite. So let's just quickly start with 6.1. So here's 6.1. They say calculate the derivative of f from the first principle, which is worth 5 marks, So how can we derive this one? So to use the first principle, we're going to make use of this formula. This is what we use for the first principle. What I always tell my student is how easy it is, these questions of using a first principles, because the reason why this is because you know the answer before you start answering. Also, if you can derive this is going to be f prime of x. It's going to be, this one is going to give us 6x, and then this one is going to give us -2, just like that. So our answer is going to be this one, but here on the first principle, they just want you to make use of this formula to find this answer, so if you don't know that, just know you already know the answer. You just need to show them how you're going to find it. So in this formula, what we need actually is this equation of f of x plus h, because f of x already has it. So let me just find f of x plus h, which is going to be, I'm going to substitute x plus h on the value of x there, which is x plus h square plus is it plus or is negative? Negative 2x plus h, just like that. Then from here on, I'm just going to distribute, let me just first factorize this one. So as I always tell my student this, to cram this, whenever you see a square just like that, if you simplify that, it's going to give you x squared plus 2xh plus h squared. Always, it does not change. Whenever you say x plus h and it has a square outside in the bracket, it's always going to give you this if you simplify. So let me just let this be the same. Now I want to distribute. So this is going to be 3x squared, and then 3 multiplied by 2 is going to be plus 6xh, and then plus 3h squared. And then let me just distribute this one's -2x, -2h, just like that. And yeah, this is f of x plus h, just like that. So now we can be able to like substitute this in our, and you need to rewrite your formula. So we're going to have f of x prime, which is equals to the limit as h approaches 0. Okay, since the formula is this one, I don't know, but for you, you need to write this down. But for me, let me not write it so that I can be able to save space. What I need, since I will assume that my formula is this one, what I need is just to say limit and then h as approaches 0. And then f of x plus h is this one that I have over here. Let me just write it down. There it is. And then now what I need is to say minus, and then I put this f of x, which is 3x squared minus 2x, just like that. And all of this equal to h. And then now I'm going to have limit h as it approaches 0. Okay, let me just rewrite this again, and then I will simplify them. Now I need to distribute this and then also this. So this is going to give me -3x squared. This is going to give me positive 2x, just like that. And I'm going to divide this by h. And then now, as you can see, look at this. This and this are going to cancel each other out. This and this are going to cancel each other out. So I'm going to be left with limit as h approaches 0. I'm going to be left with 6xh plus 3h squared. What else? Minus 2h divided by 2. And then limit as h approaches 0. Now I'm going to take out the common factor, which is h. I'm going to be, if I take h on the first one, I'm going to be left with 6x. And then if I take h on this one, I'm going to be left with plus 3h. Because I take 1h, I'm going to be left with 1h. And then this one, if I take h here, I'm going to be left with negative 2. Just like that. And then h. So as you can see that this is going to cancel this. What is going to be left there? So I'm going to be left with limit as h approaches 0 with 6x minus, plus 3h minus 2. So now, since I want to, I need to substitute h there, I'm going to not write this because now I want to substitute. So let me just finish this one over here. I'm just going to say f prime of x is going to be equals to, I no longer write this. Why? Is because now I want to substitute. So I'm going to have 6x plus 3, and then I put 0 minus 2. So 6x plus, this is going to give me 0 minus 2. So therefore, f prime of x is going to give us 6x minus 2, just like that. So this is our answer. This is what I was talking about, that we know the answer before it begins. Let's move on to the second question. So 6.2.1, they say determine this. So okay, so I think we need to first factorize the top one. So we need to find, we need to first find the factors of this top number over there. So we're going to have limit h as it approaches 3, So I think here they wanted to say x as it approaches 3, not h, nah? Yeah, because I don't know, maybe it's just because of this limit, but at the end where there is x, we're going to substitute it 3. They wanted to say x here. I just double check in the question paper. So first we need to find the factors of this one. So what I like to do is to just use a quadratic formula. What I always tell my students, use a quadratic formula here and then just pretend as if like you find the factors. If you use a quadratic formula on this one, the first x that you're going to get there, you're going to get to x is equals to 3. Or the second x that we're going to find there is x, which is equals to 5 over 2. So what you do on this one, I'm going to open two brackets just like this, and then change this one. This is x is equal to 3. This is the same as x minus 3, And then since this one is like this, what you do, you're going to take this denominator, attach it with x. And then since this 5 is positive, we're going to make it negative over here. This is how we find factors using a quadratic formula. This is how we find factors using a quadratic formula, but pretending as if like we just find the factors. What do I mean by that? You don't need to show them this. You can write it on a scribbler or something, but just come here with the factors only. So also this one, we need to put it in the way that we usually know it. So this is x 3 minus x. So this is the same as negative x plus 3. Why is this the same? Because 2 minus 1 is the same as negative 1 plus 2. This is going to give you 1. Even if punch this in, we're going to get 1. So hence there, we can just like put it in the way that you like. So now, we need to make sure that this denominator is the same as the numerator, which is x minus 3 there. Now we need to make this be a little bit the same with that one there at the top. How can we make so? We can take out the common factor of 1 there. We're going to be left with x and 1. What will be the number that will multiply with negative 1 give us positive 3? It's going to be minus 3, just like that. So this one we can write it as negative x minus 3 over there. And then limit as h approaches 0. And then you can see that this is going to cancel this. We're going to be left with negative 2x minus 5. And this is 3, no? So this is going to be limit h as it approaches 3. So this is going to be negative 2x plus 5, just like that. And right now, what can we do? So now we can be able to substitute. As I said, this was supposed to be x somewhere here. So now we can be able to substitute that kind of an x, which is negative 2. We put that 3 over here plus 5, It was supposed to be limit as x approaches 3, Yeah, but I hope now you can be able to see. So if you substitute 3, they're going to get negative 1, which is going to be your answer. Let's move on to 6.2.2. which is this one. They say we must derivate g of x. We must find g prime of x if g of x is equal to this. So what we do here, a lot of my students make mistakes here. We need to first put this in a way that we're going to have numbers, all of it, not fractions, because you cannot derivate a fraction, you know. So here we're going to have g of x, which is equals to, this one is okay, but this one we need to interchange. This is the same as negative 4x negative 1, just like that. Most of my students make mistake here. They think by doing this we're derivating. No, this is not a part of the derivative. We're just putting that number, fraction as a number, you know. So now we can be able to derivate. So this is going to give us 4x3, and then negative 1 multiplied by, it's going to give us positive 4x, negative 1 negative 1 is going to give us negative 2, just like that. So this is going to be our answer. If they wanted us to put in a standard form in a positive exponent, they would have said so, but since they didn't say anything, let's move on to the next. The next one is this one. They want to divide the x if y is equal to this. So here we need to first distribute this. So let me, x multiplied by 3 is going to give us 3. Okay, let me just remove these brackets actually. So this multiplied by is going to give us 3x. X multiplied by is going to give us negative x squared. And then 3 multiplied by 3 is positive 9. 3 multiplied by negative x is going to give us negative 3x. So look at this. If you pay attention, these and these are going to cancel. So we're going to have y, which is equal to negative x squared plus 9. So for the y, the x, now we're derivating. So this is going to be negative 2x, just like that, because the 1 is going to be eliminated, plus 0, because the derivative of this one is 0. So the y, the x, some of us then forget that kind of a 2. Don't forget this 0. It is necessary for you to mention, because when you derivate this, it gives you 0, you know. So our answer is going to be negative 2x, just like that. Let's move on to the next question. So our last question here of derivatives. So they want this one. So I like this kind of questions because it becomes much more easier for you to derivate when you have this. I don't know why do I say it becomes much, but for me, I think this one is easy. So the x, so this one, what we need is to first make it this. So I saw some people make mistake when it's like this. They assume this is the same as this. No, this is not the same. So what you need to do here, you need to make sure that you rewrite this. Like, in order for us to derivate, we don't need to deal with squares or fractions. So we need to eliminate squares and the fractions. So this thing is the same as root of x is the same as x over 1 over 2. Why is this so? It's because even root 2 is the same as 2 1 over 2. If you don't believe me, you can go and do this by a calculator there. You're going to find that this is the same. So I'm going to put 3 the same, and then x, this is going to be 1 over 2 over them, minus 4, this one is okay, over, also this one is going to be x1 over 2. So since we have fraction here, we need to separate those kinds of fractions. So we have the x, which is, so we need to separate this. So this is going to be 3 1 over 2 over x 1 over 2 minus 4x 1 over 2. This is still the same thing, because if the denominator is the same, we can add what is at the top or subtract them, because the denominator is the same. So as you can see, the main reason why we did that is because we want to separate numbers from the variables. So these two, I mean this one is going to cancel this, so the x is going to be left with 3, and then you're going to be left with, we can take this one to the top, just like we did on the first question. So we're going to have 4, and then when we take this one to the top, it's going to change sign. The exponent is going to be negative 1 over 2, just like that. And then dy dx. Okay, yeah, good. So now we can be able to derivate. So when what we were doing here, we're not derivating. We're trying to put this in a standard form by eliminating roots and the fractions, you know, Perfect. So now we can be able to derivate. When you derivate, you can drop this. You no longer need it. You can drop it down. So here we're going to have, if when the derivative of a constant is 0, and this one, -4 multiplied by 2, I mean -4 multiplied by half is going to give you positive 2x, and then minus 1 is going to give you -3 over 2. So our answer is going to be 2x -3 over 2, just like that. So this is going to be our answer for this question. Let's move on to the next. So now let's move on to 6.3. There's a determine the equation of the tangent to f of x at x is equal to -2. So a lot of people, guys, whenever they see this type of questions, they start to panic. So the equation of the tangent, it is given as y, which is mx plus. It's a straight line, actually. That's something that you must know, So in order for us to find the equation of the tangent, what we need first is the gradient, We need to find the gradient. So on cubics or on calculus, to find the gradient, we know we're going to derivate f of x. So we're going to derivate f of x, which this is going to give us 2x, and then the derivative of that is going to be -2. For this one is going to be 0. It's unnecessary for us to write. So I don't know if your teacher has taught you this, but the first derivative is what? Is the gradient. Is equal to the gradient, perfect. It's equal to the gradient. To find that kind of a gradient, actually, we need to substitute a point that is passing through that kind of equation, which is this x minus 2. So in terms of x, if we substitute this -2, we're going to find our gradient. So we're going to put this -2 over 2 -2 minus 2, just like that. And then now we can be able to find our gradient. And then if you punch this in your calculator, you're going to get -6. Wow. So our equation right now, let me just erase this. Our equation right now is y, which is equals to -6 x plus c. So what we need right now, we're almost there. We need the value of c. So to find the value of c, we need to substitute one. We need to substitute one point that is passing through that kind of an equation, So where do we need? We need to substitute this x value on the original equation. Bear in mind, not on the derivative, but on the original equation. So to find that one, I'm going to find the point of contact. It is called the point of contact, actually. So I'm going to substitute this -2 on the original equation. So I'm going to put -2 squared minus 2, and then we'll put -2 plus 3. So this, if you punch this in the calculator, you're going to get 11. Good. So our point of contact, what is our POC here, is going to be the x value is -2 and the y value is 11. So this point is what we're going to substitute here. So we're going to sub what? -2 and 11. So whenever there is y, you're going to put 11 negative, and whenever there's, you're going to put -2 plus c, just like that. And then this is going to give us positive 12 plus c, and then 11 minus 12 c. Our c here is going to be equals to -1, actually. So y is going to be equals to -6x minus 1. So this is the equation of the tangent at this point. So now let's move on to the next question. So now let's move on to question 7. So question 7 is a cubic function, which is, it carries almost 11 marks. Yeah, quickly, let's just start with the first question. So 7.1, guys, don't mind these pictures. The question paper was a little bit, so I have to adjust it, something like that. But now let's focus on the question. This in the sketch is defined by f of x. Points A, B, and C are the x-intercept, good. And then they say T is the y-intercept. So this is important. And then D and E are turning points. So the first question, they say determine the coordinate of E. So E, they say, is what? Is the turning point. So how do we find the turning point of a cubic? We derivate. So we're going to find the f prime of x, which is, this one's going to give us 3x squared. Then when we derivate this, it's going to give us negative 10x. And another one is going to be minus 8. So f prime of x, this is very important to write. It has to be equal to 0 for us to find the turning point. It is very important for you to write that one down. So since f of x is this one, we can write it down. Minus 10x, which is minus 8, which is equal to 0. So right now here, they want the factors of this, and you cannot find the factors if you don't have the coefficient of 1. And also, even if you divide, it's still going to deal with the fraction. However, you can use your quadratic formula, but a quadratic formula in your paper is going to take a lot period of time if you want to like show all the calculations, because they say show all the calculation. Rather, what you can rather do on this question that I always recommend to my student, use a quadratic formula here, and then on your calculator aside, and just come back here and write those kinds of factors. Just like, let me just explain using it. If you use a quadratic formula on this equation, your first x, you're going to find that is equals to 4. The second x, you're going to find that is equals to negative 2 over 3. So what you do, since you know, in order for us to achieve this, we need to have x minus 4. In order for us to achieve this, what we need to first attach this with x, so 3x. Since this one is negative, here is going to be positive 2, If you like this, you do it aside and just place that one there on your paper. This is going to help you manage your space, because during your exam, they're going to give you a small answer sheet, which is a little bit small. So using a quadratic formula is a little bit long, so, but if you use this kind of a method, it's going to be very, very easy. And this one is the best in everything, actually, So our x, we already know it, but we just pretend as if you don't know it. X is going to be equals to negative 2 over 3. So this is the x value of the turning point. So to find the y value, so okay, let's just locate. E is on the positive side, so it means that D, the x value is this one, but this one is for E. So to find the y value of this one, I'm just going to say f of 4. We're going to take this 4 and substitute it on the original equation. We'll put 4 square minus, look what I'm doing. I'm going to substitute it on the original equation. Since I already substituted it here, if you go and substitute, then you're going to get negative 36. So E, all in all here, let me try to erase this. So E, let me also erase this one over there. E is going to be equals to 4 and negative 36, just like that. Perfect. So then the next question, they say right. Once they say right, it means that it is very easy. The tangent, the equation of the tangent ME to F. So they wanted this equation of this one. So since we know the point of this one, E, is 4 and negative 36. So it means that this is the horizontal line, actually, So for 7.1.2, our answer here is going to be y, which is equals to negative 36, because here is 36. If here is 4 and negative 36, it means that also even this equation is going to be y, which is equals to negative 36. It's just a horizontal scale. It's parallel to the x-axis over there, perfect. So moving on to 7.1.3, they say write down the length of TM. Also they say write down because they know it is easy. So 7.1.3, and then they want the length of TM. So here's T and here's M. So M is going to be what? Since yes, that is negative, it's going to be 0 and negative 36. Look at T. What will be T be equal to? T is the y-intercept they told us here. So y-intercept is 12. So T is 0 and 12. So if here is 12 and here is negative 36, what will be the distance of this one? So to find TM, what you need to do, we're just going to take the top number minus the bottom number. You will find the answer. So the top number is 12 minus the bottom number is negative 36 over there, and then this one is going to, let me just punch this. is going to give us 48. I'm sorry guys, I don't know why these things always like make it like, oh, it's going to be unit because this is just a distance, you know. Yeah, let's move on to the next question. The distance of this one is going to be 48. Yeah, perfect. So now let's move on to the next question. So our next question, gentlemen, is 7.2. This P of x is a cubic function. First, let me just explain this before we go far. We know that when we have a cubic, if our A is positive, it's going to be concave up. It's going to start like down and go up just like this. If A is less than 0, our graph is going to be concave down. It's going to go up first but goes down at the top. That's something that you need to know, you know. So they say P of x is given this equation, and then they say A is equals to, so we know that this one is going to be, our graph is going to be like just like that. And they say P of 0 is equals to 0. So when we substitute 0 on the original equation, we're going to get 0. So they're giving us the coordinate. And something to be aware of, if you substitute something on the original equation, they give you 0. What is that? Remember, what is that? It's the factor. And the factor is what? Is the x-intercept. So we have x-intercept, which is 0 and 0 here, you know. Because if you take a number, remember when we are looking, why do we look for a factor? It's when we want to look for the x-intercept. We take any number from 1. If the one that is the one that when we substitute on the original equation, it gives us 0. It means that that number is a factor. And a factor is the x-intercept. So look at this one. They say P prime of x. What is this actually? This is the turning point. Remember, how can I make people understand this? Okay, I will explain it. So this, it means that when we substitute, actually they've given us the x value of the turning point, not the y value, because some other people, they will be tempted to say that the turning point is going to be 1 and 0. No. This is the x value. Remember, let me just, what can I do to make you understand this? Okay, let me just try to scroll back. Maybe I'll find something over here. Oh, good. Here it is. Here it is. Here it is. Okay, let me just try to erase this. I just want to convince you what I'm trying to say. So what is f prime of x here? So f prime of x is this equation that we just derivated. Yes, 3x squared minus 10x minus 8, you know. So when they say f prime of something, it's just like the same. They are talking about this x value. When they put 4 here, if you put 4 here, you're going to get 0, you know. But this, it does not mean that the coordinate of the turning point is 4 and 0. No. This, it means, like it's just the usual way whenever you're looking for them, because when you're looking for the turning point, you always take f prime of x and equate it into 0, you know. So when they put 4 here, it does not mean that the turning point is 4 and 0. Pay close attention to that. However, if it was f of x, they put 4 and is equal to 0, this was going to be 4 and 0. But for that one, it's not the turning point, you know. It's just they're giving us the x value only, but the y value, we don't know. So I hope that it has helped some of you to understand. So here, okay, let me just write, this is 0 and 0. And then this one, the turning point they've given us is 1, and the y value we don't know. And also on this one, they've given us is 3. It's the turning point. These are the turning points, actually. It's 3 and y we don't know, you know. So they say use the given information to draw a neat sketch, show all the intercept and the turning points. So hola, let's just show them. So let me just try to draw this. Okay, cool. So what do we have first? It has to pass through the origin, and our shape is going to stand something like this. So hopefully it has to come something like this over there, you know. Good, like that. So the turning point here, let me just try to, the turning point is going to be 1, you know, but that 1 is going to be a 1, but the y value we don't know. We know the x value only. And then also this one is going to be 3 is going to be here. So this one is going to be 3 and y over there. So yeah, perfect. So this is 0 and 0 if we want to just mention it for them. So I think for this 4 marks, they're going to give you for a shape, and then for showing the intercept, the turning point. I don't know what is the 4th mark over here. is 4. Yeah, but they're going to give you 4 all in all. Yeah, because we don't know this one, we don't know that one. Yeah, it's going to concave down just like that. Good. Yeah, and then this one is going to be like this. I'm just trying to confirm if it's correct. Yeah, according to me it's correct. For this one, guys, you can comment the comment section if you see something wrong to 7.2. I'm not sure with this because when I checked the memo, they didn't draw the same graph as this one. But for me, I think this one is correct because we don't know the y value. On the memo, they assume 3 is 0, which I don't agree with that. It's okay to disagree. Even you can disagree with me. Yeah, but without further ado, let's just move on to the next question, guys. So question 8, this is an optimization question. This type of questions a lot of students always like skip. So this one carries 9 marks. So let me just give you a best recommendation ever. Guys, I have a playlist of measurement. In order for you to understand this, you need to understand a lot about measurement, which I have a playlist on. If you go to the description box of this video, down there I've put the link to the playlist, which is for grade 11, whereby we cover measurement. If you, since now you're left with few days to write your exam, if you can go through some few questions there on that kind of a playlist, it's going to help you a lot to understand the shape, because on optimization you're going to be always given some certain shapes which you need to know measurement in more details. Perfect. So some of the things here, when I explain, if you don't know measurement, it may not make sense to you, and then don't assume that these things is tough. It's not tough. You just need to just take a look at it. If you can go through that kind of a playlist, it's going to help you a lot to gain more confidence before you coming to the questions of measurement, of optimization, yeah. So let me just quickly start with the first question. So gentlemen, our question is going to be this one. They say the figure represented the large stained window frame. So this is the window frame actually. These are those kinds of windows from church, something like that. Have you ever saw some windows like this at church? That is just a little bit like this. Yeah, I saw some of them on this Catholic church around. Yeah, so this is it. So they said the upper part of the frame is the semicircle. Good. So this is important. It's the semicircle. The lower part is the rectangle. Good. So the 2x we can see it, and the y we can see it. Another important information, they say the perimeter of the window frame. So the whole of this shape, yeah, it has a perimeter of 30. The first question, they say show that y is equals to 30 plus. That's why a lot of people start to like go far. They hate pure maths because of this type of stuff here. So, but what you can understand here, this 30 that is over here, the only way we can be able to achieve 30 is by using the perimeter of all of this, perfect. So we need to find the perimeter. Okay, let me just explain it let me just write it down. The perimeter of the whole frame here is equal to the perimeter of what? Of a semicircle plus the perimeter of a what? Of a rectangle. Perfect. So we need to add these two perimeter in order for us to give us that full perimeter. Perfect. So since we know a rectangle, this side is also equal to, it means that this one is also equals to 2x. So since this one is the top part is the semicircle, it means that from here on, this part is x and this one is x, because x plus x is going to give us this 2x that is there. Perfect. Something to be aware of. So first thing that you must understand, where it's going to get a little bit weird if you don't know some of the things. So we need to first find the perimeter of the semicircle, actually, perfect, the semicircle. But we know the perimeter of a circle is equal to a 2 pi r. This is the perimeter of the full circle. I also teach this, guys, on that kind of a playlist if you want to go through those kinds of stuff. So and this is for full circle, but here we have a semicircle. So for a semicircle our perimeter is going to be, we're going to half this. So like I know we need the half. Let's just divide by 2 on the full one. We divide by 2. So the perimeter of this one is going to be pi r, perfect. So our r here, what is our r? Our r is x, our radius is x. So this is like this. So now we did find the perimeter of the semicircle. So the perimeter of the semicircle is what? Is pi r, is pi x, is pi x, just like that. Good. So now that we find the perimeter of the smaller circle, we need to find the perimeter of what? Of the what is this? Of the rectangle, actually, perfect. So when we talk about the perimeter, we talk about, we add all these sides, actually, perfect. Since we already added this one on the semicircle, we cannot add it on that kind of a square. So I'm going to add these two sides and also this one, because this one is already added on that semicircle. So the perimeter of a rectangle is going to be equals to, we add this 2, is going to be 2y plus this 2x there, which is 2x, perfect. So the perimeter, all of it, of this frame is going to be equals to, let me just start with this 2y plus 2x, and then plus pi x, just like that, perfect. So now the perimeter we're given of this whole frame is 30. So 30, which is equals to 2y plus 2x plus pi x. So on this one, they want the value of y. We need to make y side of the formula. So I'm going to take all this to the other side. Minus 2x minus pi x is going to be equals to 2y. So now I can divide both sides by 2, and this is going to cancel this. Y is going to be equals to 30. And then now I can be able to take a common factor, which is x over there. I'm going to take x out, and then if I take x, I'm going to be left with 2. There I'm going, since it's negative, it's outside, so this one is going to be positive pi, such that when I take negative x and I multiply with this pi, I'm going to get the negative pi x. So I'm going to divide by 2, and this is what they wanted us to prove over there. So yeah, let's move on to the next question. So our next question is, they say calculate the value of x for which the area, look at this, now they're talking about the area of the window frame, which will be maximum. Whenever you say maximum, it means that we need to derivate the area, So we need to find, let me just try to take a calculator over there. So we need to find the area of this thing, actually, all of this. Guys, okay, let me just sit properly. We need to find the area of this whole thing that is here. So this 5 marks, guys, is not for small boys, it's for the G's, actually, So for the area, guys, we need to first find the area of a semicircle. So let me just first find the area of a rectangle, because I think this one is going to be very easy. So the area of a rectangle, let me just say rect, is going to be length multiplied by height. So our length is this one, which is 2x. Our height is going to be y, just like that, perfect. But here they say we must calculate the value of x, so we need to substitute. We don't want a lot of y's there, because if we're going to finding the area of this one, we're going to make use of our x. Okay, let me just not confuse you more. I will do it later, but let me just do it now. I want to resubstitute this y, because we want to solve for x over there. I just want to do it right now so it can be able to be very easy. So we know that y, we done it previously, is equals to 30 minus x over 2 plus pi square. Yeah, good, just like that. So if you have forgotten, yes, what did I just substituted here? We've proven it on 8.1. So now we're using it on 8.2. So okay, cool. Now let's just solve this. So right now, how can we solve this one? Okay, look at this 2 is going to cancel out with this one, and I am going to be left with x, and then this is going to be 30. Let me just distribute this one, minus 2x and then this one is going to be minus x pi x, just like that. So these two is cancel out with that kind of a 2. So this one is going to be 30x minus 2x squared minus pi x squared also, perfect. So what is this area? This is the area of a rectangle, so we need to find the area now of a semicircle. Remember, to find the area of this whole thing, we need to first find the area of this small one and the area of that one, then we add them together. So now we're going to find the area of a semicircle. Yes, also something is going to confuse you if you don't know this. The area of a of a full circle is equals to pi r squared. So if we want the half of it, we're going to divide this by 2. We're going to half that one, So for this was going to be half a pi r squared, perfect. So it's going to be 1 over 2 pi. What is our r here? Remember, we calculate this is x and x. Our r is going to be x squared because our radius is x. Half there is x, Cool. So now we did find the area of a semicircle and the area of a rectangle. What can we do? Now we're going to add them. The area of the full frame of the window is going to be equal to the area of a rectangle plus the, let me just say this one for rectangle is 30x minus 2x squared minus pi x squared. I'm going to add it with 1 over 2 pi x squared. So as you can see right now, there's like terms here. I don't know if you guys noticed this, but this is this like term of this one, So this is like negative 1 plus 1 over 2. I don't know if someone sees that. Negative 1 plus 2. This is what it is actually over there. So here, if we add those kinds of like term, we're going to have 30x minus 2x squared. And then negative 1 plus 1 over 2 is going to give us negative 1 over 2x squared. Just like that. Oh, I forgot the pi. Let me write pi x squared. Just like that. So this is the area actually of this thing. Let me just write it in terms of x. So now they want the maximum. So we need to derivate this. So we're going to have a prime of x, which is going to be equals to, this is going to give us 30, and then this is going to give us minus 4x, and then if we derivate this, oh, I forget the pi here. What is the pi? Oh, I didn't forget the pi. Everything is settled here. Yeah, everything's like a settled. So okay, so 2 multiplied by 2 is going to give us negative pi x, because 2 multiplied by 1 over 2 is going to give us 1, and when we subtract 1 there, it's going to give us that one. So now we're derivating, guys. Perfect. So we know that when we derivate, I don't know if your teachers taught you this, but when we derivate, this is like finding a turning point actually, the f prime of L, the first derivative, it has to be equal to 0, So we need to take this 30 minus 4x minus pi x, which is equal to 0. Look at this. On our question here, they say that we must leave our answer in terms of pi, but we're solving for what? For x. So that means here we need to solve for x. So I'm going to take, okay, let me just simplify this. I like to do things simply. What can I do? Okay, let me just take out the common factor between this. Yeah, since I'm solving for x, I'm going to take x over here. And this is 4. And then there it's going to be positive pi. So when I distribute this and also this, it also bring me back where I come from. So I want to solve for x here. What can I do the first way? Okay, the first way, I think if I take this is negative, this is the one thing, this thing here is one term. This is like negative 2x actually, perfect, because this is negative 2 multiplied by x, if you don't understand that. So I'm allowed to take all this to the other side. I'm going to be left with 30, which is equal to positive x over 4 plus pi, just like that. You see, I take this negative x pi to the other side. So now I can divide by 4 plus pi and 4 plus pi, just like that. So this is going to cancel this, and my x is going, why did I say my x? This is not my x, guys. Like, this is what I hate about maths. They're asking us to solve for the x, for their x. It's not our x, actually. This is not my x. I don't know, guys, if it is yours. This is not mine. So 4 pi. So this is their x, not my x, good. So this is the value of x that they are looking for. And then we have reached the end of this particular question paper. If you found this video useful, you can subscribe to the channel. And also, guys, if you would like to join my online classes, text the number below. And bear in mind, online classes aren't for free. I saw some people text me expecting questions. It's not for free. It's $250 per month for maths only. So for more information, when you text me, just know, good, like, you all be aware, good, you already understand, good, like, this is this and this. So just texting me. If you can text me with the way to join, then I can be able to, like, give you absolutely everything, the information, and enroll you in the group. So this is it for this video. See you on my next video. Sharp.